Module 42, the foreign exchange market. In the last module, we saw how differences in the supply of loanable funds from savings and the demand from loanable funds for investment spending lead to international capital flows. We've also learned that a country's balance of payments on the current account plus its balance of payments on the financial account add up to zero. A country that receives net capital inflows must run a matching current account deficit, and a country that generates net capital outflows must run a matching current account surplus. But what ensures that the balance of payments really does balance? What ensures that the two accounts actually offset each other? It turns out it's the exchange rate. In this module, you will learn the role of the foreign exchange market and the exchange rate, and the importance of real exchange rates and their role in the current account. Go ahead and pause the video for a second and set up your notes for this first section of the module. Suppose you were traveling to Mexico and you wish to buy a t-shirt at a market and the price is 187.5 Mexican pesos. You have US dollars in your pocket, but you must pay the store owner in currency most useful to her, the peso. How does an American get his hand on some pesos? He must exchange his dollars for pesos in the foreign exchange market. Now, your typical tourist will do that either at a bank or there are foreign exchange windows where you can go and make those exchanges. How many Mexican pesos does one US dollar fetch at the foreign exchange counter? Well, it depends on the exchange rate. In mid-June 2010, one US dollar could buy about 12.5 pesos. Or, if you were in Mexico and you wanted some dollars, it would take about 12.5 of your pesos to buy $1, which means 1 peso would be worth about 8 cents. So how much does the shirt cost in dollars in June of 2010? To find this out, we divide 187.5 pesos by 12.5 pesos, or 12.5 pesos per dollar, because 187.5 pesos is the cost of the shirt and 12.5 pesos per dollar is our exchange rate. And we find that it's about 15 US dollars. Now, the exchange rate is just a price. In this case, 12.5 pesos is the price of a US dollar. And we know from many previous models that price changes are based on the forces of supply and demand. Now, if we look at April 2010, it took 12.1 pesos to buy 1 US dollar. So in that month, your dollar would have been able to purchase fewer pesos. How much would the shirt have cost in April 2010? 187.5 pesos divided by 12.1 pesos per dollar is equal to $15.50. In other words, the dollar was more expensive as measured in pesos per dollar in June than it was 2 months earlier. If we look here, we see that indeed $1 cost 12.5 pesos in June and it only cost 12.1 pesos in April. In other words, the dollar was more expensive in June than it was 2 months earlier. Economists would say that the dollar has appreciated in value against the peso from April to June because it became more expensive. Another way to think of that is look at what happens to the price of the shirt. From April to June, the price of the shirt measured in US dollars drops by 50 cents. Our dollar was stronger in Mexico because it could have bought more of everything priced in pesos. What happened to the value of the peso? In June of 2010, 187.5 pesos would have bought $15. In April, it would have bought $15.50. In other words, in the span of 2 months, the same amount of pesos bought fewer dollars. Economists would say that the peso has depreciated against the dollar. The price of the peso, measured in dollars, has fallen. Here we have exchange rates among the world's 3 most important currencies as of 9:40 a.m. on April 30th, 2010. And notice the specific time. Exchange rates often are changing by the minute. Each entry shows the price of the row currency in terms of the column currency. For example, the US dollar exchanged for 0.7479 euros, and so it took 0.7479 euros to buy 1 US dollar. Or it took 1.3371 US dollars to buy 1 euro. Now, these two numbers reflect the same exchange rate. 1 divided by 1.3371 is equal to 0.7479. People tend to express the exchange rate as the price of a dollar in domestic currency, but this isn't universal, so travelers pay attention. Now, why is all of this important in our macroeconomic world? Movements in exchange rates, other things equal, affect the relative prices of goods, services, and assets in different countries. But what determines exchange rate? Supply and demand in the foreign exchange market. Pause the video here and summarize this first page of notes before you get started on the next section. Go ahead, stop again, and set up your next section of notes before we continue. If I want euros, I demand them. In order to acquire euros, I must supply dollars to the exchange market. So when Americans demand more euros, they supply more dollars. The graph below shows the market for the US dollar. Now, because we are considering dollars and euros, notice that we have the quantity of US dollars on the horizontal, and then our price is now the exchange rate. And we're always going to have it set up so that you have the price in terms of the price of one currency in terms of another. And you're always going to have the one on the bottom on the vertical axis that is on the horizontal axis. So, on our x-axis, we have the quantity of the US dollar, supply and demanded, and on the y-axis, the price of US dollars measured in euros per dollar. So how many euros does it take to buy a dollar? Why does the demand for dollars slope downward? Well, as the price of the dollar falls, its value depreciates. It takes fewer euros to buy $1. Consumers in Europe will find U.S. goods to be less expensive. U.S. exports to Europe will rise, and more dollars will be demanded to pay for those goods. Why does the supply of dollars slope upward? As the price of the dollar rises, its value appreciates. $1 buys more euros. Consumers in the U.S. will find European-made goods to be less expensive. U.S. imports from Europe will rise, and more dollars will be supplied to pay for those goods. Suppose demand for U.S. dollars increases. Maybe European countries have more money to spend, and some of that additional income is being spent on financial investments in America. The payments from those European citizens will flow into the U.S. financial account. As the demand for dollars shifts to the right, the equilibrium price of dollars rises and the dollar appreciates. It will now cost more euros to buy $1 US. Because the US dollar has appreciated against the euro, American consumers will be able to buy more goods and services from Europe, so more dollars are supplied and will flow out of the U.S. current account. Because the quantity of dollars demanded and supplied is the same at the equilibrium exchange rate, the increased quantity of dollars demanded must be equal to the increased quantity of dollars supplied. This tells us that any increase in the U.S. balance of payments on the financial account is exactly offset by a decrease in the U.S. balance of payments on the current account. Our summary: an increase in capital flows into the U.S. leads to a stronger dollar. This creates a decrease in U.S. exports. A decrease in capital flows into the U.S. leads to a weaker dollar, which creates an increase in U.S. net exports. So, the foreign exchange market follows those laws of supply and demand to create our equilibrium exchange rate. To understand the significance of the equilibrium exchange rate, it's helpful to consider a numerical example of what equilibrium in the foreign exchange market looks like. Such is the hypothetical example shown in Table 42.2. The first row shows European purchases of U.S. dollars, either to buy U.S. goods or services or to buy U.S. assets such as real estate or shares of stock in U.S. companies. The second row shows U.S. sales of U.S. dollars, either to buy European goods and services or to buy European assets. At the equilibrium exchange rate, the total quantity of U.S. dollars Europeans want to buy is equal to the total quantity of U.S. dollars Americans want to sell. Going back to the fact that current account has to be equal to negative financial accounts. If you need to, pause the video to take a minute and fully examine this table. Now, let's briefly consider how a shift in the demand for U.S. dollars affects equilibrium in the foreign exchange market. Suppose that, for some reason, capital flows from Europe to the foreign exchange market. Say that, for some reason, capital flows increase due to a change in preferences of European investors. The effects are shown here. The demand for U.S. dollars in the foreign exchange market increases as European investors convert euros into dollars to fund their new investments in the United States. This is shown by a shift to the right of the demand curve. As a result, the U.S. dollar appreciates. The number of euros per U.S. dollar at the exchange equilibrium rises. What are the consequences of the increased capital inflow for the balance of payments? The total quantity of U.S. dollars supplied to the foreign exchange market must still equal the total of quantity of U.S. dollars demanded. So the increased capital inflow to the United States, an increase in the balance of payments on the financial account, must be matched by a decline in the balance of payments on the current account. What causes the balance of payments on the current account to decline? The appreciation of the U.S. dollar. A rise in the number of euros per U.S. dollar leads Americans to buy more European goods and services and Europeans to buy fewer American goods and services. Here we see how this might work. Europeans are buying more U.S. assets, increasing the balance of payments on the financial account from 0.5 to 1. This is offset by a reduction in the European purchases of U.S. goods and services and a rise in U.S. purchases of European goods and services, both the result of the dollar's appreciation. So any exchange rate or any exchange in the U.S. balance of payments on the financial account generates an equal yet opposite reaction in the balance of payments on the current account. Pause the video here and summarize this page of notes before we continue to the next section. And again, pause the video and let's set up this last set of notes before we continue. The price of imported goods depends on the exchange rates for foreign currencies, but also on aggregate price levels in those nations. To take into account the effects of differences in inflation rates, economists calculate, you guessed it, real exchange rates to adjust for inflation and international differences in aggregate price levels. Suppose that the exchange rate we've been looking at is the number of Mexican pesos per US dollar. The real exchange rate between the Mexican peso and the US dollar will be Mexican pesos per US dollar times the price level in the US divided by the price level in Mexico. To distinguish it from the real exchange rate, the exchange rate unadjusted for aggregate price levels is sometimes called the nominal exchange rate. There is no difference, let's say, in aggregate price levels between the US and Mexico in the base year. So let's say that the exchange rate is 12.5 pesos per US dollar, and let's just say since this is the base year, that the price level in the US is 100 and in Mexico it's 100. Well, 12.5 times 100 divided by 100 is 12.5 pesos per dollar. Now, let's say the Mexican economy suffered 10% aggregate inflation, and so in our second year, the price level for the US is still 100, but in Mexico it's 110. So, our real exchange rate is now 12.5 times 100 divided by 110. This equals 11.4 pesos per dollar. Even though the exchange rate hasn't changed, inflation in Mexico means each US dollar will buy fewer pesos and thus fewer Mexican goods. This is going to have an effect on the current account. Figure 42.3 illustrates just how important it can be to distinguish between nominal and real exchange rates. The line labeled nominal exchange rate shows the number of pesos it took to buy a US dollar from 1990 to 2009. The peso depreciated massively based on this line. But the line labeled real exchange rate shows the number calculated using our equation with price indexes for both Mexico and the United States set so that the value in 1990 was 100. In real terms, the peso depreciated between 94 and 95 and again in 2008, but not nearly by as much as the nominal depreciation. By 2009, the real peso-dollar exchange rate was just about back where it started. Pause the video here and summarize this last section of notes. Here are some interactive activities and some practice problems to help you review concepts from this video. I would highly encourage you to visit the Refenomics website and check out some of these interactive modules and get some extra practice on these ideas. This is the last slide of the video. Review your notes, add your own examples where you can, mark questions you wish to discuss in class tomorrow, and make sure you bring those questions so we can discuss them.